Everyone, we are finishing up our limit on limits, and so we're just going to do a little bit more practice using the different strategies that we've learned. So first, we have the limit as x approaches 0 of x minus 5 squared minus 25 over 0. So if we plug in 0, we end up getting 0 over 0, so we know that there's something else we have to do. So this leads us to possibly the easiest of our techniques, which is to factor. I see that I have a difference of 2 squares. Okay, I know that this is a group, but I still have a difference of 2 squares, so I can factor this. So I have the limit as x approaches 0 of x minus 5 plus 5 times x minus 5 minus 5 divided by x. Okay, so looks like some things will cancel. I end up with the limit as x approaches 0, and this is something you might be wondering, like, do I have to write the limit every time? Yes, you have to write the limit every time until you evaluate it. Otherwise, it'd be like literally omitting a multiplication sign or the fraction bar or something like that. You just wouldn't do that. Alright, so these 5's will cancel. I have x times x minus 10 over x, and my problem spot cancels. That's a good thing. Remember, whatever is inhibiting you from being able to plug in your point, that's what you're looking to cancel out. So I have the limit as x approaches 0 of x minus 10, which is just going to be negative 10. Next one, I have a complex fraction. So this is going to be our combine fractions strategy, or get a common denominator, however you want to think about it. Alright, so in order to get a common denominator, I'm going to multiply 1/4 by 4 plus x over 4 plus x. I'm going to multiply 1 over 4 plus x by 4 over 4. And do not combine, that will just make your life harder. So I will end up with 4 over 4 times 4 plus x, keeping these separate, minus 4 plus x over 4 times 4 plus x all over x. Limit as x approaches 0. Alright, now I can combine my fractions. So I have the limit as x approaches 0 of 4 minus 4 is 0, and then just negative x, all divided by x. Alright, so this is good. These x's will cancel. Again, if you don't see that, you can rewrite this as times 1 over x. Okay, these x's will cancel. I'm left with the limit as x approaches 0 of negative 1 over 4 times 4 plus x. So plug in 0 for x, we'll end up with negative 1 over 16. Next one, I have a square root. This is where we're going to rationalize the numerator, or in other words, multiply by the conjugate. Okay, so I'm going to multiply by the square root of 25 plus x plus 5 over the square root of 25 plus x plus 5, and multiplied by the conjugate. So I will end up getting 25 plus x minus 25 over x times the square root of 25 plus x plus 5. And again, do not combine. This will make your life harder. Alright, these 25's cancel. I'm left with the limit as x approaches 0 of x over x times 25 plus x plus 5. Alright, now I clearly see my x's cancel. That was my problem spot. And so I have the limit as x approaches 0 of 1 over the square root of 25 plus x plus 5. Great. So now if I plug in 0, I will just end up getting 1/10. Fantastic. Right. Super simple. Alright, so next one, I see a trinomial, I see a difference of 2 squares. Perfect candidate for factoring. So I'm going to factor the numerator. So this looks like 5 and 3. So x minus 5, x plus 3 on bottom, x minus 3, x plus 3. Great, this will cancel, and I'm left with x approaching negative 3 of x minus 5. Ooh, let's try that again. X minus 5 over x minus 3. So now if I plug in negative 3, no issues. I end up with negative 8 divided by negative 6, or 4/3. And look at that. Okay, next example, similar to what we did in our last notes. Okay, so what I want to do is use my limit rules and kind of split this into different functions. So I'm going to consider this as 3x, and my signum function shifted to the right by 2. Right, so if we consider this 3x, no issues, I can just plug in 2. Right? So I'll get 6 times. Now I have to consider what's going on with my signum. So if you don't remember, my signum function looks like this. It's just we've shifted over to be at 2. So I want to know what's happening as I approach from the left. I'll be at -1. So I'll get -6 as my answer. If you're not comfortable with this parent function, then just take a look at it and do a little practice. You'll be fine. Alright, next one, for some reason again, the GIF did not print. But I'm going to consider this as 3 separate functions. So I have the limit as x approaches 2 from the left of 3x, 1 over x minus 2, and the greatest integer function shifted to the right by 2. So plug in 2, I get 6 here. I consider what's happening with my reciprocal function as I approach from the left, so I'm plugging in smaller numbers. I will approach -infinity. And then right here, as we did before, I'll get -1. Alright, so this 6 just kind of gets absorbed by the infinity, but these negatives will cancel. So I end up with positive infinity here. Alright, moving on. Okay, so now I have examples of my special trig function. So if you don't remember, it is the limit as x approaches 0 of sine of x over x is 1. Cool. So what I need is for top and bottom to match. So what I need is an x. I need this happening here. I don't have that here, but I could easily get that by factoring. I see that I have 2 x's in common. So I have the limit as x approaches 0 of sine of x on top, x times 5x minus 8 on bottom. So now I see I have a sine of x and an x. So I can use my limit properties and consider this as 2 different functions. Cool. So I know that this is going to be 1. If I plug in 0 here for x, I will get -1/8. So my final answer is just -1/8. Alright, now I have a lot more happening here, and again, if you don't recall, all I need is for this to match. So if I had sine of like 5x, I would need a 5x on bottom, okay, or the reciprocal. So if I had the limit as x approaches 0 of 2x on top, I need sine of 2x on bottom, right? Those just need to match. So I'm just going to expand this. I have the limit as x approaches 0 of, alright, so I have sine of 2x on top. I have a sine of 3x on bottom. I don't know why I didn't do parentheses there. And then I have a 5 over here just chilling. Right, so let's fill in the blanks on what we need. I actually didn't need that. Let's fill in the blanks on what we need. So if I have a 2x here inside my parentheses, I also need a 2x here. But I cannot just divide by 2x, I also have to multiply by 2x. And same thing, if I have a 3x here in my parentheses, I also need a 3x up here. But I cannot just add a 3x there, I also have to divide by 3x. And that is what we have introduced to our equation. Okay, so I multiply by fancy 1. The nice thing is that these x's will cancel, otherwise this would get kind of complicated. So this will be 1. This will be 1. 5 is just 5. And 2/3 is what's remaining from my x's that I added. So 1 times 1 times 5 times 2/3 is 10/3. And that's it. Hey, that is limits. So if you can work through these, maybe not as quickly as I did, but if you can work through these, you can work through just about anything that you would need to for this class. So go ahead and start working on your next worksheet. Let me know if you have any questions, and have a fantastic rest of your day.